Hello, thanks for having me. Yeah, so I've joined Zalando about 3.5 years ago. Before that, I was actually a postdoc researcher in Berlin. But for some reason, I always liked to create software and just writing these papers and then waiting for reviews for years and months. That somehow didn't make. That wasn't that much fun anymore. So I joined here, and when I joined, I first started as we call delivery lead for recommendation and search. So two teams who are already using a lot of machine learning. But then about 2 years ago, Zalando started creating this kind of principal track where you don't have to manage so many people, but rather focus on the thing. And then I thought, okay, I've done the research for 10 years. So maybe I can do something else than telling people how to write proper emails when responding to requests. Anyway, so but I think what's really interesting for me was that sort of coming from that huge methodological sort of focusing on the methods kind of approach, right? And then sort of seeing in a company, okay, what is actually needed. And I want to share like 3 different areas that I've learned a lot about in the last years, and I hope it's not something that you already know. All right. So I think usually when you go to conferences, big data conferences, machine learning conferences, like there's a lot of focus on 2 things, or maybe 3 things. So one is the algorithms, right? Deep learning, the newest algorithms, very cool stuff. Then there's a lot of talk about tools like Spark, TensorFlow, right? And lastly, there's sometimes a bit of discussion about, okay, what do you actually need in a company? How do you structure the company? So this is a bit my sketch of this AI hierarchy of needs. So who has heard about this thing before? Nobody? Okay, this was a Hacker Noon post, right, by somebody. Unfortunately, I forgot the name. Who wrote that like you need this AI hierarchy of needs, like so there's this like human. Oh, okay, I also forgot that name. Anyway, there's this idea of there's a hierarchy of needs, so you have to start with sleep and food, and then you work your way up, and then at the very top you have sort of self-realization and eternal blissfulness, right? But you need the things at the bottom to get to that on the top, and they say, so everything starts with data, right? You need to collect the data, you need to have it in a way where you can move it around and store it, and so on, and then simple aggregations, and so on, and then at the very top is AI, but you cannot just say, okay, let's everybody learn TensorFlow, and then let's do AI. Okay. So, but the question still is, so these 3 things together, is that already AI or not? And I think like there are at least like 3 things which are missing, and I'll come to that now. Okay, so the first thing is, right, so usually, because also the training for machine learning very much focuses on the algorithms, there's often very little question on how the algorithms actually fit the business problems. Because in a company, right, let's be honest, so companies are about solving customer problems to make money. And you want to make money because you enjoy solving customer problems so much that you need the money to do that in a sustainable way, right? It's not about the money, of course. Okay. So so who of you knows, is Zalando selling in Sweden? I should also know that. Yeah? All right. So who has bought something at Zalando already? Okay, very good. So you know what it is, right? It's a website. We sell shoes. Okay. And usually, so the way you think about what you do to solve the customer problem, right, is so the customer has a certain job to be done, very abstractly speaking. For example, he wants to buy shoes. And what you have to build is you're going to build a product that helps the customer solve this job, okay? And in order to solve, the product itself consists of different activities that you have to make, right, which are part of the product. And usually there's like one of the activities, at least then it gets interesting for us, right? There's one of the activities which could be solved with machine learning, right? But the task is sort of, so you don't start with the algorithm, but actually you start with the customer and think about, okay, what is it that he or she wants to solve? And then you think, okay, is there some part of the activity that makes sense? Okay, I'll come to an example a bit later. Right, in machine learning, so you probably all know this, but my very, very, very super high-level view, or how I try to explain this to people who are also not very technical, is to say that sort of machine learning is a different way of creating programs, right? So the classical approach is you write down the requirements, you give it to a coder, and then after 2 weeks he comes back with a solution. So this is the idealized version, of course. But the problem is there are many problems where you cannot simply write down what you actually want. right? So for example, if you want to do image recognition, right, you say, I want to have a program that tells me whether there's a cat in the image. So the definition of what it means that there's a cat in the image is very hard to write down in a way that's just easy to put into code. So what you can do instead is you can have many examples of images and say, okay, in this image there's a cat, in this image there's not a cat. And then machine learning sort of, on a very high level view, is an alternative way of creating the program by learning from examples. Okay. So one example, of course, very specific to me, is recommendations. So the customer wants to buy a new shoe, and part of the job, so there are different jobs that sort of he has to do, or she, to buy the shoe. So for example, browse the selection, compare prices, inform themselves about materials, pick and select, and then pay, right? Sort of the whole pipeline of what you need to do to buy a shoe online. And the product that we have is essentially the website. And then there are different activities that we have to do to make the website working. So one is to retrieve and display a selection, to filter the results, show article details, right? So for the materials, you want to show article details, maybe close-up photo of the fabric and so on. And one of the activities we do is to show similar articles, right? Because it's a very convenient way of browsing, right? You have this shoe, you say like, this is almost good enough, but maybe not. Maybe, right, there's a better shoe, and then you want to see similar shoes. And then there's checkout and all the other stuff down there. Okay, and so this show similar articles, that's an activity actually, right, which is very hard to, or it's difficult to do that well, just writing a program, because it's not really clear what similar means, right? So what does similar mean? So we sort of know what similar means, but it's very hard to teach a machine what to do that. So on the other hand, there's a lot of example data available. If you look at how customers are browsing the website, then you can see, first they look at this shoe, then at the other shoe, maybe they compared them or something, right? So you have all this click data, and if you have a fairly large website as we do, then you have a lot of data. And then you can sort of use the data to figure out what similarity means. Yeah, and it's also a typical problem for machine learning, but this is something you have to do fairly often. So even if you sort of took like a group of 50 experts and they came up with the perfect rules for each of the different categories, what similarity means, it's still difficult. Because you have new articles every day and might change all the time, so you can maybe once produce this big rule set, but then improving that from day to day as you get new articles is also not realistic. Okay, so what we've done, sort of, is to translate this thing that says, okay, show articles similar to the given one. So this is sort of the business problem that we have. And now what we have identified that this is a good case for machine learning. But now if you closely look, you see that actually the machine learning problem is different. So you don't say show similar articles, but you sort of reduce that to another problem with this machine learning, which says given two articles, the probability that the customer will click the other, right? And then once you have this, you're able to compute this probability for all articles, right? Then you can sort them by click probability and then get the top ones, right? But which is, on some level, a slightly different problem than what the business person thinks about. And the other difference sort of is that sort of the metric for the business side is, so you want to show similar articles, and you want to measure success by whether the customer finds something they like or not, right? So whether they buy it or whether they click it. So conversion rate I wrote down, so whether they buy it, okay? But from the machine learning view, the question, so because the task is slightly different, it's also that you have a different metric down there, which is essentially the accuracy, whether the probability that you predicted is correct or not, okay? And this is, again, like I think, so once you start working with machine learning and this product development cycle, this is like details, but which in the end make it very hard and lead to misunderstandings, right? So the machine learning person on the right-hand side, mostly concerned about accuracy, right? So you start doing everything cross-validation, you look at the outcome and so on, and then you say, yeah, we have 70% accuracy, 80% accuracy, but the real problem you want to solve is this customer problem on the other side, right? And this is sort of slightly different things you're talking about. And sometimes this leads to problems because you forget to think about, okay, how does this prediction probability accuracy actually translate to solving how good the customer problem is, right? And especially if you have like a product, so I'm talking a little bit about that in the end also. So usually there's like a product manager who is responsible for the left column, the left one, yes. And you're responsible for the right column, right? And if you're not aware that you're actually talking, so you're solving the same problem by talking about slightly different things, there can be confusion. Okay. And now if you go through these things, actually there are, so this was one example, right? So it's a bit of like a selection example, but there are many things like how business tasks translate into machine learning tasks. So if you want to make a decision, so on the business product task or business side, you often talk about you want to make a decision, right? You have two different options. You want to figure out what is the best for you or for the customer. You want to rank options or you want to optimize an outcome, right? So it's all about like very high level thing. But on the other hand, what you often do in machine learning is more like you classify an input, you predict something, you predict a score, or you do this forecasting, right? And so this slight difference, this is sort of what you have to keep in mind. Okay. Yes. And there's a different problem, don't want to go into too much details here, is also the question, so how do you actually, if you have the prediction accuracy, so how can you make an estimate for what the metric for the real customer problem is, right? And that's sometimes really hard, for example, with recommendation, because if you start with historical data, you cannot really go back in time and just show other recommendations, but you can sort of compute how well you predicted what happened in the past, but you still need to do this thing, and then you can think about how to simulate that well. All right, so this was the first part. The second part is sort of, so how do we actually build these systems that have machine learning at their core? Because if you look at like a typical real-world system, right, so the machine learning is the small box in the very middle. But if you start, so you have the customer here on the screen, yeah, we have different databases, logs, where you collect the data. You have something that actually pulls the data in for the training jobs, does a lot of feature extraction and so on. And then comes the machine learning part, and then the output of that is a model, and then you have to put the model into production, which means you have to, usually you have like a number, like a scaled out cluster of servers, which each individually load in the module, right, to serve, for example, recommendations to the customer again. But on this, you also have to have monitoring. And of course, so this whole pipeline here should be automated. And sort of the whole thing here down, that's your product. And the machine learning is only the small part in here. Okay, right, and this is, so usually, sort of if you come more from a research background, you really focus on this here. And everything else, so this part usually does not really exist because you're more thinking about offline evaluation. You just want to know how good the algorithm is. And the whole part here, the whole data extraction, that's something that you maybe do once or twice manually, right? You know, until it's really good. But if you want to put it into production, you have to automate everything. Okay, and in the second part, I want to talk a little bit about like typical architectural patterns that you have to do this thing. All right. So I have like a catalog, so it's a bit like the design patterns for software architecture, right, just for machine learning, and still very early on. But I think in general there are like 5 different areas. So one is typical patterns around the core machine learning, right? I think this is, if you come more from an academic background, this is what you're probably most familiar with. Then there is the part, how do you actually serve the predictions, right? How do you get them out in real time? The data pre-processing and the features, automation and monitoring, and the last part is sort of machine learning integration. This is sort of the technical side of how to put the machine learning algorithm into a bigger technical infrastructure to serve something. Okay, so I won't go through all of them, but I will just, I think, 3 of them. Okay, so core machine learning, right? So this is probably, hopefully, very familiar to you. So usually you have some data, you do pre-processing, you split the data into training and test, you train your model, and then you apply the model on the test data to get an error estimate. And then you sort of, this is the basic setup that you have, and then you can iterate until you have something that sort of works well. Okay? And I think already, so we're also working a lot with, so in Zalando we have many software engineers who are actually very interested in machine learning, right? And we have internal courses for them. And this is, of course, the first thing you always learn, right? You don't look at the training error, right? So the first thing is always they train something, you say, yeah, 100% accuracy, but you say, no. So you have to split the data and then do this whole thing to get a realistic estimate of how the model really works. Okay, so the serving patterns. So I'm now always thinking about this case where you have a model, let's say for recommendations, right? And then you need to have the predictions in real time. And so, and depending on your requirements, so there are at least 3 patterns I frequently see of how to apply the model. So so the most basic part is, of course, you do it offline. So you train the model, you apply it to your data, and then you put that in a database. But let's say if you actually want to have it. So the first part is sort of you embed the model. So you have the application, and then in the application itself, you have a piece of code that can do the prediction. And then you sort of, when you start the application loads the model, and then it has it embedded in the application itself, right? The second part, so I'm going through the 3 parts first and then explain a little bit what the differences are. The second part is sort of it's a bit like the this offline case, right? So you get the data, you apply the model, they put it in a database, but then the serving part actually takes the predictions from the database to do the prediction. And then the third part is that the model is sort of standalone as a microservice, as a REST service or so. Okay, so the last part, that's actually the part that gives the data scientists the most independence, right? Because they can just sort of, they fully own the whole piece of the code, and they can just, whenever they want, they can deploy a new model, they can switch the traffic and so on, everything works. But the problem is that, so usually all of these interfacing takes some time, so this does not work if you have to do like 1 million requests or so per second, because you're actually using the model to optimize something else. So this is something, if you're in that kind of setting, then you actually need something like this, where the model is really internal to your application and you can query it very, very often. This part, actually, this works quite well if you have a model that is pretty slow, right? Like a really big deep learning model. But also the application domain isn't so large. So for example, we are using this if we have a model which is very costly, but we only apply it to all of our articles, because these are like a few 100,000, so you can just compute all of them, put them in a database. They also don't change that much, right? So every day we get a few thousand new articles, so the base is relatively stable. And then you sort of decouple the whole model from the serving part, and then you can put it in a very fast database, like in memory, like Redis. And then you just have, so it's not, so the speed of the model is not really a problem. All right. So another problem is sort of how to do the pre-processing on the data, right? To compute the features that you need for the model. So this is more a problem if you don't use deep learning, which usually has this somehow built in. But if you have more classical models, as you know, because then you first need to take the data and pre-process it so that you can use it. Okay. So and the problem here is sort of, so there are 2 lanes down here. So let's say we start with some real-time data, like click data, right? So you have for all your customers, you want to do again, think about recommendation, that's the easiest example. So you have the click data, and actually you want to do the prediction based, for example, on features which you compute from the click data, right? So how many visits per day, some features like that. So, and one way to do it is sort of every time you do a training, you extract some of the data down here to the batch data, you pre-process it, then you have your features, you train, and then sort of everything's good. The problem sometimes is that, so what happens to when you have new customers who weren't there at training time, right? So let's say you train once in the morning, and then during the day you have new customers, but you don't have features for them, right? Because you haven't computed them. So if this is really, really important for you, if you don't have any other fallback for these new customers, then what you can do is you can sort of have a mirror version of this pre-processing down here, and then instead of, so you do like the training here, okay, so you do the batch training here, but the features you compute in training, you also put into key-value store. Again, something very fast. And then at the same time, you have sort of, then during the day in real time, you have a mirror version of that process running here that looks at the data in real time and also computes the features and updates them down here. And then at the serving time, you sort of going back to the feature store to compute the features, right? So a customer comes in and you want to know what are the features of the customer. So either you have it from training time or they came maybe back during the day, and then you have it here. And if you do it right, if sort of these two things are written in a way that they can work with streaming data, it could even be the same code. So this is a bit like what they call the Lambda architecture often in the streaming analysis, but sort of applied for feature engineering. Okay, and then the last part is sort of, so now they have the machine learning, and as I said, usually there's a business problem, and then there's the machine learning, and there's some relationship between them, right? And if you look at many of these different use cases, you realize there are also different ways of how actually machine learning is used in a bigger thing. So one is, the first of this is sort of scoring, right? So you have, again, think about recommendations. You have a model that, for example, predicts click probability, but what you really want to do is figure out what are, let's say, the 10 most interesting items for the customer. So what you're doing essentially is to use the model here just as part of a scoring, right? So every time you get a request, you try to get a candidate set that is already interesting, and you score all of these items, and then you take the top ones. So another thing, another way to use machine learning is completely for pre-processing. So if you think about self-driving cars, right? So one part where they use machine learning is for object detection. So it's really so the raw sensor data comes in, and then they do the object detection, and the output of the system is then something that's used later on, right? So it's different from here. It's not for scoring. It's really sort of one part in the processing pipeline. The third part is sort of, it's a bit similar to that, right? But sort of what you're doing is you're trying to train a model that forecasts, thank you. Okay, 2 minutes. So that a model that somehow tries to predict what will happen if you do a thing, right? And then you have something on top that does training to figure out, that sort of does optimization to optimize something else based on the predictive model that you have. So for example, if you look at AlphaZero, this Go program from Google, right? This is exactly the way how they use it. And then the last way, of course, is you have machine learning sort of end-to-end. Okay, so short of time, maybe the last thing, so organizing machine learning teams. I think for me, the most important, or what I often see what the sort of the problem is, if you have teams where you put data scientists and machine learning and software engineers together, right? There's always a bit of a cultural clash, because what the developers are working on, so sort of the range here is between exploration and actually coding, right? So the data scientists, they focus more on exploration, and that also is reflected in the way how they code. So you code something, you try something out, you don't really need, the next day you come in, you say, okay, let's try something new, right? You forget the code from yesterday, and then on the third day you say, oh, actually, there was something good I did the day before yesterday, and you make a combination of that, right? So it's from a developer perspective, it's very messy, because for developers, sort of building the code, that is what they do, right? So they are like building a house, and they want to have a good foundation, and they want to have code which they can still maintain in 2 years' time. And when the question is always, how do you put these? So I believe that it's very good to have these two groups of people work together, right, on a common product. But the question is also, how do you organize them from an architecture point of view so that they work well together? And something that I think doesn't work so well is when you try to really separate the two parts, right? So if the data scientist is working on a problem, and then they write a paper, and then to bring it to production, somebody else needs to pick it up and write it down, because it takes so long. You cannot really iterate, so you do this once, but if data science have to do another iteration, they don't really know what's in production and so on. So what we're trying to do is to have a way where the data scientist sort of also owns the part of the production system that is the core algorithm, and then they work very closely together with the data science, with the engineers. So the engineers are also interested in helping them, providing a framework where they can fit in, and then that way you bring the two groups closer together. All right. Let me close with things to think about, right? So I hope this was also thought-provoking for you. So 4 questions. So what business problems are good candidates for machine learning, right? So really try to think from the customer's perspective. Don't just think in terms of algorithms. You want to apply what kind of architecture patterns frequently occur, right? So once you know how to do that, you don't have to rethink it every time again. How does data science work differently from software engineering? All right, and the last part is how do you want to scale the work up? So this is more like an organizational thing, but unfortunately I don't have time for that. Okay, thank you very much.
Thank you so much. And now we have some minutes for questions. There's one in the middle row on the right.
Thanks for a great talk, Mikio. So looking at this, I see that there's quite a lot of maturity in your infrastructure. Did it look like this when you joined Zalando, or how long has this process taken?
Okay. Yeah, so I think when I joined Zalando, we already had a few teams, like the recommendation team, who already did this for a few years, and they were actually pretty mature, right? So as I think Zalando always had a very strong focus on having reliable infrastructure, and they already had high standards for that working. I think what changed in the years till then is that now we're also trying to make this scale across the whole company, right? So that we don't have just these, like, I don't know, 5 teams who have been doing this for a while and know what they're doing, but actually that we have the right infrastructure for all the teams to be on that level of maturity. And for that, sort of, you need like central tools, central infrastructure. So I haven't talked about this, but we invested a lot in a data lake. Now we're sort of starting with with machine learning tooling, like a central Jupyter notebook hub, and things like that, so that teams don't have to start from scratch. Yeah.
Question here in the front. You can start if you want to, or.
I like what you said about matching business problems to data science tasks and problems. How at Zalando do you leverage this for innovation, which usually needs a bit of a product design part and a technical part?
Yes. Yeah, I think the idea is to have the data scientists, I think in a way, so product development and data science, they're more similar than, let's say, classical software engineering, because they're both very researchy, right? So product design is all about figuring out how to solve the customer needs. And if you look at all this agile, so a lot of it's actually about, it is exactly the same. Let me just get back to the slide, right? So it's the slide I skipped. Okay. So it's exactly this kind of process that you do, right? So you talk to the customer. It's not like you say, like, so would you use this? But you actually try to figure out what they want, and then you do a prototype and show it to them, and then you figure, does it work or not? And if you think about, like, data science is the same thing. So you get some data, you try to figure out whether it works or not, and then you do the next cycle. So the way how this works with innovation, to come back to your question, right? So I think the important thing is that the product people and the data science, they work very closely together already very, very early on, right? And we have had very successful projects where actually they really started thinking about so it was around algorithmic outfits, right? So now in Zalando, if you go to an article, you actually get a whole outfit recommended. And they started actually not with machine learning, but just like what is the right way to show this to the customer? What is the right way to talk about what is presented, so that the customer doesn't have, like, the wrong expectations about this, right? And then later on, and I think this just used, like, handcrafted algorithms, outfits in the first place, and then the machine learning came later on, right? But to have the flexibility to say, like, okay, first we have to do this, or let's do machine learning first. I think that's very important. And then, so the key is, I think, to have these people work very closely together in the beginning. All right.
Thanks again for this amazing talk.
Thank you very much. Okay.